I see this as the core question. We're investigating how changing the epsilon radius, eps, and the minimum samples, min_samples, in the dbscan algorithm impacts the resulting clusters. It's about understanding the interplay between these two parameters. Let's dive in. This is the instruction for the multiple choice question. I need to choose all the statements that accurately describe the effect of eps, and min_samples. I interpret this as, if I lower the minimum number of points needed to form a cluster, I'll likely end up with more, smaller clusters. It's like lowering the bar. More groups will meet the criteria. This means the radius size, eps, directly influences which points are considered central or core points of a cluster. A larger radius will identify more core points, while a smaller radius means fewer will qualify. I understand this to mean that increasing the search radius will lead to fewer, larger clusters. Points that were previously in separate, smaller clusters will now be grouped together because they fall within the larger radius. This is a quiz testing your understanding of how changing the parameters in the dbscan algorithm affects the clustering results. Let's get started. This question focuses on how the epsilon and minimum samples parameters impact dbscan's clustering behavior. It asks you to identify which statements accurately describe the effect of altering these parameters. Get ready. This sets up the scenario. You're using dbscan with specific parameter values. I'm curious to see how you interpret the effects of these values. Let's analyze these parameters and their impact. This is about how increasing the radius for searching neighbors in dbscan affects the number of clusters. I want to see how well you understand that increasing the radius to search for neighbors increases the likelihood of merging smaller clusters and results in fewer clusters. Think of it this way. It creates bigger clusters. This statement explores the effect of lowering the minimum number of points required to form a dense cluster. It checks if you know that lowering this threshold makes it easier to form clusters, hence resulting in more clusters. A decrease leads to more clusters forming. This statement tests your understanding of core points within dbscan. I would like you to check if you know that the radius, eps, directly determines which points are dense enough to be considered core points for their surrounding clusters. Think of eps as the radius and how its size determines how many points qualify as core points. This explores your understanding of how min_samples affects different point classifications in dbscan. Do you know that min_samples influences both core and border points? Since a core point's definition also depends on the value of min_samples, it's essential to correctly interpret how min_samples affects both core and border points. I'll explain the crucial parameters in dbscan, a density-based clustering algorithm. We've got EPS, epsilon, and minsamples. These control how the algorithm groups data points. Think of it like this. Eps sets the radius around each point, and min_samples sets the minimum number of neighbors within that radius to create a cluster. This is the radius around a data point that dbscan uses to search for neighbors. It determines which points are considered close enough to be in the same cluster. I think of it like the range of a spotlight. A larger EPS means a wider spotlight, encompassing more points. This parameter sets the minimum number of points needed within the EPS radius to form a cluster. If a point has fewer than minsamples neighbors within its EPS radius, it's considered noise. I see it as a crowd size requirement. A point needs enough nearby companions to form a group. I see eps as the radius of a circle I draw around each data point. Any other points that fall within this circle are considered neighbors. A larger eps means a bigger circle, finding more neighbors. Think of it like this. If you're looking for friends within a certain distance, eps, a larger distance, bigger eps, means you'll find more friends. Pretty straightforward, right? This is the minimum number of neighbors a data point needs to be considered important enough to be part of a cluster. I think of it as the friend threshold. To form a group, you need at least this many friends. A smaller min_samples means you need fewer friends to form a group. Makes sense? This is where the magic happens. Based on the size of the circle, eps, and the number of friends needed, min_samples, we decide which points belong together. Points that meet the requirements become part of a cluster. Simple as that. I'm assessing your understanding of how changing the epsilon, eps, and minimum samples, min_samples, parameters affect the results of dbscan clustering. dbscan, by the way, stands for Density-Based Spatial Clustering of Applications with Noise. I'm asking you to identify the true statements about how changes in eps and min_samples affect dbscan's output. It's a multiple-choice question. Absolutely. The epsilon, eps, parameter is super important. It defines the radius around each data point. Points within that radius are considered neighbors. Core points need a minimum number of neighbors within that radius, and eps directly defines how big that radius is, therefore impacting core point identification. You got it. The min_samples parameter sets the minimum number of points needed to form a dense cluster. If I lower that number, it becomes easier to form clusters because fewer points are required to satisfy the density criteria. Nope, this statement is incorrect. Min_samples influences both core points and border points. A point is a core point only if it has at least min_samples points within its eps radius. Border points are within the eps radius of a core point but don't meet the min_samples requirement themselves. So, min_samples affects the core points and that, in turn, affects border points. That's right. If I increase the epsilon radius, I'm making it easier for points to be considered neighbors. This means that smaller, separate clusters might merge together to form larger ones, resulting in a decrease in the total number of clusters. I'm analyzing how changing the epsilon, eps, and minimum samples, min_samples, parameters in the dbscan algorithm affect the clustering results. dbscan, or Density-Based Spatial Clustering of Applications with Noise, is a powerful clustering technique. We'll see how eps and min_samples are key to its functionality. Let's explore this next. If I reduce the minimum samples needed to form a cluster, I'll get more clusters. Think of it like this. If you need fewer friends to be considered part of a group, you'll have more smaller groups overall. Now, let's focus on epsilon. Epsilon is the radius used to search for neighboring points. If I change the radius, it directly changes which points are considered close enough to be neighbors, and that completely changes what is considered a core point. This is crucial for dbscan. Okay, let's consider increasing epsilon, the radius. A larger radius means more points are considered neighbors. It's as if I'm using a bigger fishing net. I will catch more fish, but the groups will be larger. This leads to fewer, larger clusters. Finally, I'll examine how minimum samples impact clustering. Minimum samples affects more than just boundary points. It decides whether a point becomes a core point in the first place. This affects whether we get a cluster and how many points are in each. It's not just a boundary point issue. I see this as the core question driving our understanding of the dbscan algorithm's parameters. We'll analyze how changes in eps, epsilon, and min_samples directly affect the way dbscan groups data points. It's all about how dbscan defines clusters and noise. Imagine min_samples as the minimum number of friends you need to be considered part of a group. If I lower that number, it becomes easier to form a new group. Similarly, with a lower min_samples threshold in dbscan, fewer points are needed to form a cluster, leading to the formation of more, smaller clusters. Makes sense, right? Think of eps as the radius of a circle around each data point. Eps decides which points fall inside this circle, influencing whether a point is considered a core point. A point surrounded by enough neighbors to be the center of a dense cluster. A larger eps means more points are close enough to be considered neighbors, potentially creating more core points. A smaller eps might reduce the core points significantly. It's a big deal. Let's imagine eps as the distance you can see around you. If I increase that distance, I can see more people, merging smaller groups into larger ones. Similarly, a larger eps in dbscan means more points are considered neighbors, which leads to fewer, larger clusters merging smaller clusters. That statement is incorrect. Min_samples doesn't just affect border points. Those within a core point's eps radius but not core points themselves. It also directly influences core point identification, which fundamentally affects how clusters are formed in the first place.